My name is Dr. Tishan, and in this video we are going to look at regular convex polygons and their interior angles. Let's start by talking about what is meant by a regular polygon. When you see the word regular in front of a polygon, it means your polygon is both equilateral and equiangular. Equilateral meaning the sides are all equal in length, and equiangular means all the angles are equal in measure. So whether you have 3 or 4 or 5 or 6 sides, the sides will be equal length and the angles will all have equal measure. That's what's meant by regular. Also, we want to say triangles. Triangles is a polygon with 3 sides. A triangle contains 180 degrees. This is a couple of pieces of information we need before we actually derive our formulas here. So triangles contain 180 degrees. We're going to build everything off of that. So let's take a look at the board here. We're going to use this chart to see where these formulas come from that we want to use to find sum of interior angles of a regular polygon and one interior angle of a regular polygon. And then we'll do an example. So starting over here, number of sides 3. When you have a polygon with 3 sides, what do we call a polygon with 3 sides? It's called a triangle. So it's called a triangle. Now, number of triangles, well, that's where you're going to come up here from one vertex, draw the diagonals of the polygon. Well, in a triangle, you can't draw a diagonal in a triangle. So we only have the one triangle in a triangle, okay? Some of the interior angles, well, a triangle contains 180 degrees, okay? So a triangle contains 180 degrees. You only have one triangle here, so you're going to take that one triangle, multiply it by 180, and you get 180 degrees. So the sum of the interior angles of a triangle will always be 180 degrees. What about one interior angle if it's a regular polygon? Okay, so regular, so that means, regular means the angles are equal measure. So if you have a sum total of 180 degrees and you have 3 angles there, then one interior angle, you would take the sum of the angles and divide it by how many angles, how many sides we have. When you do the division, one angle would be 60 degrees in a triangle. All right, so let's go to a 4-sided figure. What is the name of a polygon with 4 sides? The name of a polygon with 4 sides is quadrilateral. So quadrilateral is the name of a polygon with 4 sides. You may have heard some other special types of quadrilaterals with special properties. For example, a trapezoid is a special type of a quadrilateral because it has a pair of parallel sides, or a parallelogram, rectangle, rhombus, squares. Those are all special types of quadrilaterals. But basically, a polygon with 4 sides. A polygon with 4 sides is called a quadrilateral. Right? Now, how many triangles? Well, let's go to our 4-sided polygon up here, and from one of the vertex, just from one vertex, I'll put it right here, from one vertex, we're going to draw all the diagonals that we can. So you're not going to draw this way as over this side. Here's a diagonal, and then we're covering this side here. So we can only draw the one diagonal. All right, so the one diagonal that we can draw breaks our quadrilateral into how many triangles? You see we have 2 triangles here. Each of these 2 triangles contains 180 degrees. So what is the sum of the interior angles of our quadrilateral? We can see our diagonal took our quadrilateral, broke it into 2 triangles, and if you take the 2 triangles and multiply by 180 degrees contained in each triangle, you get 360 degrees. So quadrilaterals contain 360 degrees with their angle measures, the sum of the angle measures. Now, this quadrilateral, if it's a regular quadrilateral, all the angles are equal measure. We have 4 angles, okay? So if you have 4 angles and it's regular, that means the 4 angles equal measure. Then we can compute what each angle must be. You would take the sum total of all 4 angles, 360 is what that 4 of them add up to. We know we have the 4 angles, divide by 4, 90 degrees, okay? So if you have a regular quadrilateral, which is also called a square, right? Then angles are 90 degrees, all right? Let's go on to a 5-sided polygon. A 5-sided polygon is called a pentagon. How many triangles? Well, from one vertex of our pentagon, let's draw all the diagonals that we can. All the diagonals, we can draw a diagonal to here, a diagonal to here, okay? So when we drew all the diagonals from one vertex, it broke our pentagon into how many triangles? It broke it up into 3 triangles. Each of these 3 triangles containing 180 180 degrees in each of the 3 triangles. So what is the sum total of the interior angles of a pentagon? It's going to be your 3 triangles, contains 3 triangles. Each of these 3 triangles contain 180 degrees. When you multiply 3 times 180, you have 540 degrees. The sum of the angles of a pentagon would be 540 degrees. If it's a regular pentagon, all the angles are the same measure, then what would each angle need add up to? Well, you would take the sum total, 540 degrees for the 5 angles, add up to 540 degrees, divide that by 5, and you have 108 degrees for each of the individual angles. All right. What is a polygon called with 6 sides? Okay, we call that a hexagon. Call that a hexagon. How many triangles? Well, from one vertex, let's draw all the diagonals that we can. Okay, so when you go from one vertex and draw your diagonals, we can break our hexagon into 1, 2, 3, 4 triangles. So we have 4 triangles here. All right, each of these 4 triangles contain 180 degrees. Okay, so you have 180 degrees here, you have 180 degrees here, 180 degrees here, and 180 degrees here. So the angles of a hexagon, 4 triangles times 180 is 720 degrees. Angles of a hexagon always add up to 720 degrees. So if it's a regular hexagon, all 6 angles are equal in measure, then what's the measure of one angle? You take the 720 and divide it by your 6 angles, and you end up with 120 degrees. So here's a little pattern as to how you work this through. Now, let's see where the formulas come from. Let's go ahead and take this information and see if we can generate the formulas that we use so we can apply it to polygons with more than 6 sides. Okay, so what is the name of a polygon with n sides? So we just traditionally call it an n-gon. Okay, you put the number of sides dash GON, and that's what a polygon is with n sides. Okay, number of triangles. Well, we want to look at the information here. Let's come up with a pattern. Okay, so let's take a look. We have 3 sides, it's 1 triangle. Okay, polygon with 4 sides forms 2 triangles. Polygon with 5 sides forms 3 triangles. A polygon with 6 sides, 4 triangles. Well, when we have n sides, what's the pattern here? What is the pattern? Do you see that you take the number of sides, you take away 2. Take the number of sides when you subtract 2. So if you take the number of sides and subtract 2, it tells you how many triangles you can draw when you go from one vertex and draw the diagonals in. So the number of sides minus 2, that is the expression that we would use to figure out how many triangles you have. Once you know how many triangles that you're breaking this up to, what is the sum of the interior angles? Well, each triangle contains 180 degrees. We want to take the number of triangles, which is the n minus 2 expression, and we want to multiply it by 180 degrees, and that is how you're going to get the sum of the interior angles. That is where this formula comes from, to get the sum of the interior angles of a polygon. Right? Now, what about one interior angle? What did we do here to get one interior angle? Well, in the numerator, didn't we take this sum? We took this sum. What is the sum here? It's going to be n minus 2 times 180. So we took this sum, okay, and we divided it by what? Okay, 6543. We divided it by the number of sides. So the number of sides here is going to be n. So here is how you would find the measure of one interior angle of a regular, right? A regular convex polygon. All right. So here are the formulas. These are the formulas. This is where they come from. All right. Now let's do an example so we can apply the formulas. Let's do this example over here. Let's find the sum of the measures of the interior angles and one interior angle of a regular 12-GON. Okay. So this 12-GON, this is a polygon with 12 sides. Okay, we have a name for that. We can name some of these polygons. Polygon with 12 sides is a dodecagon. So it is a dodecagon. Okay, and so what do we want to do with this dodecagon? We want to find the measures of the. Let's find the sum of the interior angles first. Okay, so let's find the sum of the interior angles. Okay, of the 12-gon. All All right, so what do we have for this sum? Well, the formula is n minus 2 times 180 degrees. Okay, so that's what the formula is to find this sum. The number of triangles when you draw all your diagonals from one vertex, because it's going to break it up. So you take the number of triangles formed times 180. Okay, so you take the number of sides minus 2, right? So number of sides 12 minus 2, and then multiply that by 180. 12 minus 2 is 10. Take 10 and multiply 10 times 180, and you get 1,800 degrees. So in a dodecagon, the sum of the interior angles is 1,800 degrees. Okay, so that's what the sum of the angles are in a dodecagon. What about one interior angle of a regular dodecagon? Okay, so what if you have one interior angle of a regular? Okay, it has to be regular to figure out one. Okay, so I'll call this a dodecagon. So what do we do here? You take the n minus 2 multiplied by 180 and divide that by the number of sides. You're going to take the sum and you're going to divide the sum by the number of sides. Okay, so what was the sum? It was 1,800 was the sum of the angles. Okay, and what do we want to do with that? We want to divide it by the number of sides, so it's divided by 12 sides. Okay, when you take 1,800 divided by 12, you get 150 degrees. So in a dodecagon, each of the 12 angles, in a regular dodecagon, each of the 12 angles would be 150 degrees. In case you're doing a project and you're working a project out with a 12-sided figure, if you needed this information, this is how you would compute it. Here's where the formulas come from. So helpful to know what, where these formulas come from, where they're generated from. So just when you're working mathematics, it's not just about how to do the problems and, not memorize them, but it's really why they work and where they come from. So it's just, things make so much more sense when you know where they come from and why they work and what you're going to use them for and so on. All right. Okay, so I hope this helps out with convex polygons, and thank you for watching. Appreciate it. Bye-bye.